well, here we can see, you know, I've put a few wires onto this board that I found in the junk box. It's been around for a long time. I have to see if they've got a date code on the other chips. So these ones are on the board, so I just wired it up. So we'll need to write a quick sketch. So first of all, we need a count. Let's give it a value while we're at it. We are going to do direct port manipulation. So data direction register L equals 255. That should set it to outputs. Bit strange. Used to working with the picks, and with the picks, a 1 is an in and a 0 is an out, because it looks like I for 1 for I and O for 0 for O. The Arduino seems to be completely round the other way around. And then we need a loop of some sort. So, oops, don't need one of them. So if I can actually read when I'm typing. We want the count to, want the loop to repeat when the count gets to 15. And then inside the loop we need to do something. So we'll just send the count value to the port. We'll delay half a second because it's not too exciting. And we'll increment the count. Right, and so I think the next is then plug it in. As you can see, it's an F because all the points on the port's high at the moment. So run the program. We'll give it a name. And there it goes. So let's say it's a hexadecimal display. It's got some, it has logic, and that's what it does. It has a strobe input, but currently on this board the strobe and the blanking sorry, are all poured down so that it displays straight as it sees it. So there we go. You know, David Watts produced his chip which on the other day, which looks similar. This is of a similar style with an embedded chip in it to do some of the work. And I thought when I saw his video, hey, I've got some chips like that somewhere. So had it to ferret around and found them. And I think in a second I'll just give a quick brief look at the datasheet. I'm back again. Well, just as an note, I thought I'd pop up the datasheet just to give a quick overview. As you can see, it's a 14-pin chip. A couple of pins are admitted, and it is basically just simply, you've got a 4-bit, something falling down behind me. You've got a 4-bit input, giving you the numbers between 0 and F as a hex. You've got a latch that latches that data in to the latch, where it then feeds the decoder. The decoder then feeds the constant current driver and lights the appropriate LEDs for the data on the input. They provide a blanking input which allows you to turn the display on and off, and there is also a left and a right decimal point. But notice these do not go through the constant current driver, and they do not go through the blanking input. So you need to provide the current limiting for these LEDs from the LED supply, and you also, if you want to move decimal point, need to provide the logic for turning it on and off. So So nice chip, but has its drawbacks that the decimal points aren't fed via the intelligence that's built in. But apart from that, I think it's nice. It looks good, and I'm going to use it because it has that kind of vintage feel. If you want to see more videos like this, down the right hand bottom corner, click on the subscribe button. Make comments, give me the thumbs up if you like it, and if you've subscribed and you want to know more, see more of my videos, click on the notification button.